All right, so here's some help on these problems with using these distributive laws. So we recorded all these, cool laws from yesterday. So let's see them in action. All right, so first one is all on distributive laws. So we're using this law here. If you have an intersect on the outside and a union inside, you can distribute it, but not just the A, but the intersect comes with it, or vice versa. But what's kind of cool is it works backwards too. So let's start with the forwards, right? I have a S union outside and I have an intersect inside. So I know distributive law can work. S union R, and I'll have an S union T, and in the middle is this. It's kind of like if there was a plus sign and you were doing multiplication distribution, that would work. It doesn't matter if it's the front or the back, so number 4 should use pretty similar. But here's something else. If you notice that they both have a intersect D, you can take that out. Right? It's like called factoring. If they both have one of these, I can take it out at the back. And guess what's left over? A B, a union, and a C. You can check if you did it right by distributing it back. That would be B intersect D. And that would be B, C intersect D, which is with a union between. So kind of cool. You can do the rest of those. Now this one simplifies as much as possible. So you're going to start, doing your little tricks here. So let's do this one here. Number 5. We'll try this. I'll show you. Simplifying means to use all your rules. So I'm allowed to use commutative, associative, identity, blah, 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 all of these rules to help me get to the end. So in here, what I notice is they all have unions. And if they all have unions, I know I'm allowed to move them around. The commutative property says you can switch the order if you feel like it. So what would help me in my brain, I'm like, I wish I could get these two guys together because I think something special is going to happen if those two guys get together. So I'm going to do the old switch with these two. I'm going to switch these. I'm only allowed to because they're all the same symbol. That was commutative. It's not bad to write down the property because that's kind of showing your work, right? I use the commutative property, and now I'm going to group these together, which is the associative property, which means I'm going to union these together before doing the B part. So what happens when you put a C together with a not C? Okay, we have that written down here. An A together with a not A is the universe. It's everything. Everything C and everything not C together makes the universe. I try to put some tails on it because otherwise it looks like a union. So this was, what was that property called? The complement property. Okay, and then last one is the null property, because if I put the universe together with B, right, universe together with A was universe, it swallows it up and just leaves you with the universe. And that was called the null set. So the end answer, it looks kind of crazy, C union B union C not, is the universe. I think you could draw a picture of this with Venn diagrams and get the same thing to work. Some people like to do that, and that's cool. Because you could be like, here's C together with B together with everything that's not C. That's your universe. That's everything shaded in. So anyway, let's do a couple more. Some of these have distributive. Now be careful, because are you allowed to just rearrange everything in here? No, because they're different symbols. So you can't use that same trick. If they're different symbols, you got to do this distributing thing. All right, so let's get to, I don't know. Let's get to number 9, because I think if you start to notice this one, you're going to be awesome at these problems. You have X intersect W naught union W naught. Now this is the law of absorption, where we said if you have one of them on the outside with an intersect and one of them on the inside with a union, it gets swallowed up by it, and it's just A. So this B is inconsequential. Or vice versa. If you have a union on the outside and intersect inside, it gets swallowed up by A. So it gets absorbed. So when I see this guy with a union and this guy with an intersect, the answer is just W naught. And the reason? Absorption. I think I misspelled it. There we go. One move. That's pretty nice. All right. So I don't know. Let's pick one of the ugly ones down here. Okay. I think you'd be okay. I don't know. Oh, let's try. I'll help you on 10. Because this one, if they were all unions, you could just scramble them if you felt like it. But they're not. This symbol is different from this symbol. So you can distribute. And what's kind of interesting is up here I just distributed, a single term. You can actually distribute this whole ugly thing. You can send this to the A and you can send it to the B. So let's try that. Okay, pretend it was just like an X. What if it was an X? You'd have X union A. But instead of X, I'm going to have this ugly guy unioned with A. And then their symbols in the middle. And then the back part would be this ugly guy unioned with B. I'm going to kind of keep grouping symbols around them. So basically, I just use the distributive property because they didn't all match. All right. Okay, so now here, is there anything I can do with this if I want to? Well, yeah, there's something you can do. See how they're all unions in here? I can scramble the order if I please, and I do please. So I would much rather it say this. Because what do I get when I put an A together with an A? Wait, I should write distributive property. And when I put an A together with an A, I get an A. Hey, shocker there, right? So it simplifies a little. So it got rid of some stuff. This was commutative property. And this was the idempotent property. Okay, and then if I work on this side, I still have this symbol in the middle, right? And then here, I'm going to get rid of my symbols, and I like putting these two together because they're all unions. I'm allowed to do that. I'm kind of just moving parentheses, which is the associative property. I didn't move their order. Here I move their order. That's commutative. What do you get when you put together a B naught with a B? So when you union a knot in itself, it makes the universe, right? So those two make the universe, and that's called the Complement Theorem, or law. And then what happens when I put an A with the universe? It makes the universe. That's the null law. So this one becomes a big old U. We don't really have space for that, do we? And then at the end, what happens? Where does this guy intersect with the universe? I'm like, where's an intersect with the universe? Here's an intersect with the universe called the identity property. A intersects with the universe at A. So this guy intersects with the universe at A union B naught. And that is the identity property. Crazy, huh? That was a hard one. Number 11 is kind of the same as far as difficulty. You can move stuff around if the symbols match. You can distribute if they don't match. It's a crazy one. And we got some on the back. This is old stuff. Cartesian products is when you make ordered pairs. Remember that. Okay. And the order they write it in matters for the X or Y part. Let's do one more and send you on your way. I don't know. How about this crazy looking one? Because this is kind of like number 11. Okay, let's do this crazy looking one. So out here, I have a union, and a union. which kind of tells me I am allowed to basically scramble these chunks up as I please. Would it help me if any of these chunks were next to each other? Because what I don't like is these guys don't match, right? I don't like that those symbols don't match, and I don't like that these symbols don't match. So what might benefit me is if I could get all the intersects together and all the unions together. So that's what I'm going to do. I'm going to scramble these guys up. So I want this guy along with this guy. So I got these two together. And I'm going to get these two together. The A not union B and this guy, B not union A. Okay, so now it's good stuff because that was the commutative property. I can, do you see these are two really the same thing if I put brackets around them? A intersect B is the same as B intersect A. In fact, that is actually how we wrote it exactly for the commutative property. So if I want to, I can rewrite this as A intersect B, A intersect B. That's commutative again. Those two are going to combine into one, right? They're going to smash, they're the same thing, so they kind of condense into one. It's like unioning something with itself, right? You don't need to write it twice. So it just boils down to A intersect B. Okay, that's what all of these do, and that is the idempotent property. IND. Okay. Now the right side is even nicer because see how they're all unions? I can scramble these in any order I want. So what would benefit me is if the two A's were together and if the two B's were together. So this is the commutative property again. So I want A naught unioned with A regular A. That's these two guys. And I want B naught or B unioned with B naught. So I want to clump them together in a better way. That's commutative and associative because I put parentheses on it. And then what happens when you put together A naught with A? Let's check. A naught with A makes your universe. That's the complement. What happens when you put B together with B naught? It's a universe. So that's called the complement. And then when you put a universe together with a universe, you get a universe. Right? That's, I mean, you could either call that the null. You could either go this route or you could go this route. Right? And then what happens at the very end when you put this guy together with the universe? It's like it swallows it up. It's another null one. Anything together with the universe is the universe. So this guy turns into the universe. That's crazy, right? All right. And remember, ordered pairs, like if I did B crossed with C, I would go 4, 1 and 4, 3 ordered pairs. And I would go 5, 1 and 5, 3. A Cartesian product is making ordered pairs where the x part would come from B and the y part would come from C. So 4, 1, 4, 3, 5, 1, 5, 3. Total number of elements is 4 because it's 2 times 2. All right, good times. Hope that helps. Finish those up. Work hard. Talk to you later, people. And do that card trick.